This is the brief on third-order tensors and their scaling constraints. All right, so we're going to dive into the world of third-order tensors. You can just think of them as these massive three-dimensional data cubes. We're here to see just how fast their data capacity explodes, and how applying some simple rules is pretty much the only way to manage that complexity. First, let's talk about the constraints that define all these components. See, without any rules, the number of independent components grows by the cube of the dimension of the space, which is, well, a lot. So to prevent totally unmanageable datasets, we use symmetry. Symmetry acts like this incredibly powerful data filter. It just drastically reduces the component count. Forcing the array to be, say, anti-symmetric or fully symmetric, well, that makes a lot of components either related to each other or just plain zero, making the whole structure something we can actually compute. Okay. Second, let's look at why visualizing this scaling is so critical. Because the component count grows by the power of 3, even moving from a small dimension, like 2, to a slightly larger one, like 7, means the number of components just absolutely explodes. When you see this visualized, maybe as a 3D grid where each point is a component, you get a really quick, intuitive feel for the sheer computational volume we're up against. Mastering the techniques that reduce this massive complexity is really the cornerstone of higher-order tensor analysis.